today we're going to test the bolt's immunity to fast burst transient pulses. These are the types of pulses you might find in a harsh industrial environment that are caused by commutation problems in equipment or brush motors or other types of switching transients. And we're using the guidelines of IEC 61004-4, which calls for applying pulses both into the power input of the bolt through conductive path and also radiated into communication ports. So we're going to start with the conductive version. This piece of test equipment can apply these pulses, and we're going with the most harsh standard, which is level 4. And with level 4 testing, the machine applies 4 kV pulses in a 5 kilohertz rate for 15 milliseconds, and it repeats this every 300 milliseconds for 10 seconds. And it does this both line to ground and neutral to ground on a power cord. And we have a Wi-Fi connection to the bolt now, looking at waveforms, and we have a scope connected in parallel, loosely coupled to this, so that we can see the pulses superimposed on the 120 volt sine wave. We have a AC power supply that is fed into the pulse generator, and the generator couples the pulses onto that 120 volt output. So I'm going to run the test, and the machine takes a few seconds to warm up, and then it will start applying these pulses, and we can see these on the scope when it starts. You can see the 15 millisecond pulses, they're much larger than the 120 volt sine wave, and if we zoom in, we can see that these are extremely narrow. They're 5 nanosecond wide rise time, 50 nanosecond duration. So those are 1,000 times faster than a single sample on the bolt. So it's very high frequency pulses that are way outside the power quality realm. So it's now applying the second set of pulses. And it has finished the test. It's applied these pulses both line to ground and neutral ground, and the bolt is still functioning normally here through Wi-Fi. So the bolt has passed the level 4 conducted test for IEC 61004-4. Next, we are going to do the first radiated transient burst immunity test. And in this configuration, level 4 pulsing is 2 kV. And instead of putting the pulses in a conductive fashion through the power cord, now the device uses this capacitor coupling network, and we have USB cable across it. And so the machine applies the high voltage pulses directly to this apparatus. This capacitor couples to the cable, and we will see how this affects the bolt. And we're still connecting Wi-Fi to make sure the bolt is still functioning normally. And here in the scope, we're actually just using a probe connected to itself as a tiny loop antenna, just to pick up the radiated field to verify that we are pulsing. So I'll run the test. This is a 10-second test, and the machine warms up. And then we can see the pulses applied. This is a 300 millisecond pulse rate. And again, these are bursts of 5 kilohertz. We can zoom into these pulses to see how narrow they are. And here on a nanosecond level time base, the pulses are, again, very, very fast. And the bolt is still running just fine. And we passed the 10-second test for the radiated test into the USB cable. Next, we will try this through the CPU input. Finally, we are going to repeat the radiated test using the CTs instead of the USB cable. So we have the flex CTs here in this coupling network, and we're going to apply the same 2 kV pulse pattern per the standard. And again, we're also connected to Wi-Fi to the bolt itself. And now we can see the machine applying this burst every 300 milliseconds. And again, we can zoom in on the scope to see that these are extremely narrow pulses in the nanosecond range. And this is a 10-second test, and it's just finished, and the bolt is still connected, working just fine. So we've also passed the level 4 radiated burst immunity test through the CP input.